Good morning. As indicated, I will present to you part of my PhD on irrigated urban greening to mitigate urban overheating, an experimental and numerical approach at the microclimatic scale of the street canyon. So in the context of climate change and with the need to find ways to thermoregulate the city, this project attempts to identify the capacity of different urban irrigation and vegetation to modify thermal comfort index in the scale of the street. So as you can see in this illustration, the area of study is complex because different aerodynamical, thermal, and radiative exchange coexist, linked to the geometry of the city, the different surface material, the thermal exchange of natural and anthropogenic region, and also these elements, they are influenced for the local climatic conditions. So as a methodology, the project is divided in three main activities: the numerical approach, so the models, they are a simplified representation of the reality. And here we are working with two softwares, OptiRig to model the plant and the water management, and ANSYS Fluent, a fluid dynamical model to model the scale of the canyon, so the urban flow. The other activity is the experimental approach. So the experimentations, they represent all the physics of the study area, and we are working with a pilot at the canyon scale. So as you can see in this illustration, the aero study have a large number of sensors in the air and also in the soil to give us the information about the different spatial and temporal scales of the flows in the study area. And finally, the experimentations give us the information about the level of simplifications that we need to apply for our numerical model, and also the database to validate our model. So we are doing this constant interaction between approaches. So concerning the numerical approach, here we have a scheme of how it works. So to simplify the explanation, the connection between the scale 1, the plant, and the scale 2, the canyon, is the impact of the plant on its surrounding. And here, this impact is felt by humidity gain and heat loss in the area. So our objective with the modeling of the whole system is to identify what the control of the irrigation in contact with the other elements of the study area can influence the variation in the thermal comfort index UTCI, and also what are our other controls in this context. Concerning our experimental approach, we built the installation during the last summer with the dimensions specified in this picture. And as you can see, in the north side of the canyon, we have climbing plants of the species Lonicera japonica, and in the other side, we have shrubs plants of the species Abelha grandiflora. Concerning the air data, here in this illustration, we have the distributions of the sensors in the air, and in total, we have 170 measuring points collating data with a time step of 30 seconds. And our operational objective with this data is to document the variation in the UTCI values in link with the type of plant and the irrigation regime adopted. For the soil data, here in these two illustrations, we have the distributions of the sensors in the 6 planters and also the height of the sensors in the soil. So in total, we have 114 measuring points, collating data with a time step of 10 minutes. And our operational objective with this data is to check the soil and the water status as a criterion for triggering irrigation. So regarding the irrigation strategy, in this study, we aim to control irrigation for two situations. The standard situation, so when we don't have a period of overheating in our pilot, we want to avoid water stress and use less water as possible. For instance, for a crisis situation, so when we have a period of overheating in the pilot, we want to provide the maximum evapotranspiration for the plant, soil, and environment system. So this summer, our own ongoing activities and expectations turns on first, identify the soil characteristics, so the soil saturation level and the field capacity. Secondly, select the most relevant variables for piloting irrigation. So taking into account the position of the sensor versus the hydric bulb geometry, as you can see in this illustration. And finally, we conducted a sensitivity analysis of the system to identify the key irrigation settings. So what the amount, the frequency, and the timing of the irrigation, how these elements, they impact the signal of our sensors. So in this way, we establish an irrigation controls and decisions rules. And now we are doing evaluation of them periodically to see if it was the good controls and rules. So after the establishment of the irrigation, this summer we are also investigating how to identify the impact of the irrigation and vegetation on the thermal comfort index, UTCI. So it's known that some factors have a major influence to the variation of this index, like shade and wind, but also the variables governing UTCI, they are impacted by irrigation. So our question is, to which extent, to answer this question, we are verifying that the management of irrigation impacts the characteristics of the soil, and in conjunction with the plant and the climatic demand, will lead to a variation in the evapotranspiration of the system. This evapotranspiration impacts 3 out of the 4 meteorological inputs of the UTCI index. So we impact the relative humidity, the air temperature, and the main radiant temperature. So our current challenge is to identify what variation we can induce with the irrigation and plant, and also in the UTCI index. So in order to identify the variation in air temperature, main radiant temperature, and relative humidity, I present in this slide some preliminary results that we are obtaining. Okay. For a day of overheating in Montpellier with constant solar radiation and a time step with 40% of the time calm wind and 0.28 meters per second as main wind. So to establish the impact of the plant and irrigation, we establish a zone in green as our reference for plant and irrigation, and a zone in red as our reference for no plant and no irrigation. So taking into account the lowest values in the green zone and the highest levels in the red zone, we have a maximum air temperature decrease of 2.7 degrees Celsius. Regarding the relative humidity near the plant, in this context, we have no significant gradient detected. And for the main radiant temperature, our spatial variation was 9.1 degrees Celsius. To emphasize the temporal aspect of our results, as well as the influence of wind as a transport and dilution element of the thermal effect in the study scenario, here we have the same spatial results taken only 15 minutes after. So in this context, we have 0% of calm wind and 1.23 meters per second as main wind. And as we can see with the increase of the speed, we observe a lower air temperature differences within the pilot area. And for this context, the maximum air temperature decrease was 1.4 degrees Celsius. Regarding the relative humidity, we observe an absolute increase along with a spatial variation of 2.6%. And for the main radiant temperature, we have also an increase in the variation, and it's 12.6 degrees Celsius. So as a perspective, the goal of this study is to contribute to the understanding of the complexity of urban metabolisms in order to take more effective actions. There are major challenges before generalizing the experimental results because they refer to a particular case of climate, temporality, and situation. However, experimentations, they are essential to understand and learn about this subject, and it's interesting to combine experimentations with numerical models, as these allow us to produce more generalizable results, compare different scenarios, and project them for future climatic conditions. Thank you.
Thanks, Martina. We've got a question from the voice at the back.
Thanks for the presentation, Martina. When you design this, is the idea is that you're simulating some kind of apartment buildings with trees in between at a smaller scale?
Exactly.
So I was wondering, because when you go from a small scale experiment like this up to 20-meter buildings or whatever, because of the length scales in the wind speed, you get very different circulation patterns. And so when you're thinking about the implications, did you see anything in the data that suggested how you would go from those small scales up to those larger scales?
Yes, I think also it depends in your reference. For example, I can say that is a scale 1 if you take into account a small street, or a scale 1/4 if you take into account as scale 1 a building of 10 meters, for example. So at the moment I'm working with the results at scale 1, but I will improve this analysis. Yes. Mm-hmm.
Thank you.
Another question?
Thank you for a very nice presentation. I'm wondering, did you attempt to look at the impact of shearing and transpiration, trying to separate the mechanism a little bit?
Yes. As I'm collecting now the data, I wanted to show something here like a result, but I want also to analyze the impact of different materials in the study area and the effect of shed. Yes. So, for example, here is evident the difference in this side is with shed and the other side without shed. So we have a difference of almost 4 degrees, and also the effect of the wood of the planters. So after I will try to analyze the impact of the different elements in the study area.
Just as a follow-up to that, is there an issue, do you think, with having 2 different treatments in the same canyon when you know that there is turbulence, and so therefore being able to identify which green infrastructure led to a change?
I thought it would be easier to identify the difference, but yes, the problem is the temporal aspect of the different effect in the study area, and also that, as I show you, in 15 minutes later, changed everything in the canyon. So you will see how to analyze.
Final question, Sebastian?
Thank you, Steve. Thank you for the presentation. I just wondered if you would also have a control site right next to it without any plants. I didn't see it in the presentation, but I think it is crucial to have that kind of control over your microclimate. So can you say something about a control site nearby?
We would like to have a bigger canyon to have a point of reference, but my objective here, it was more to see the effect in the surroundings of the plant, because I thought it would be a gradient, for example, for the humidity, or so maybe we will analyze the situations like this with 40% of the time calm winds, so it will be easier to identify the effect of each element. But effectively, with a reference point, it will be easier.
It's a very impressive experiment with a huge amount of effort to set it up. Yes. So congratulations on doing that. So if you'd like to give, Martina, is it, a welcome? Just before you run off, for those of you who are interested in irrigation, Paul Chung is going to be presenting Thursday 8:30 on his PhD research on the cooling benefit of irrigation. So a plug there. Thanks for coming.
Well timed.
On the minute we have to, I'll send an email from Danny.